All right, let's dive into a topic that's on pretty much every senior architect's mind these days. How in the world do you build a network that actually connects your multi-cloud world? So look, your infrastructure is already multi-cloud, right? You've got apps on AWS, data sitting in Azure, maybe your machine learning workloads are humming away on GCP. That's just smart strategy. But here's the real question. Did your network get the memo? Is it this beautifully designed, cohesive fabric? Or is it more like a bunch of disconnected islands that you've cobbled together over time? So, over the next few minutes, we're going to open up the Architect's Playbook. We're going to look at the core patterns for connecting your virtual private clouds, not just inside one provider, but, and this is the tricky part, across all of them. To start, I want you to get a mental model in your head. Think of your entire multi-cloud environment as an archipelago, a whole chain of islands just floating out there in a digital ocean. Yeah, each of these islands, whether it's an AWS VPC, an Azure VNet, or a GCP VPC, is built to be isolated, and that's a fantastic feature for security. But it's a huge problem when your applications on different islands actually need to talk to each other. And that's where our job begins. We have to build the bridges. So the first and probably the simplest bridge you're going to build is something called native peering. It's a tool that the cloud providers give you right out of the box. So what is it? Well, peering creates a direct private network link between two VPCs, as long as they're within the same cloud. You can think of it like a high-speed private tunnel connecting two of your islands. It uses the provider's super powerful backbone network, and it basically tricks the two VPCs into thinking they're on the same local network. Okay, here's where you gotta pay attention. Because while the concept of peering is basically the same everywhere, the way AWS, Azure, and GCP actually implement it is really, really different. Yeah, setup is easy across the board, but look at the differences in scope, and this is the big one, in transitive routing. These details can have massive implications for your architecture. And this is what that means in the real world. With AWS, peering is non-transitive. So if you connect island A to island B and then B to C, well, A and C still can't talk to each other. You have to build a third direct bridge. As you scale, this forces you into this messy, complicated full mesh design. On the other hand, with GCP's transitive model, A can talk to C right through B. This lets you build much cleaner, more scalable hub-and-spoke networks. It's a game changer. So native peering is a fantastic tool for connecting islands within the same archipelago. But what happens when you need to connect your AWS territory to your Azure outpost? This is the wall you hit with native peering. It's a hard limit. You simply cannot peer an AWS VPC directly with an Azure VNet. It's impossible. They're speaking completely different languages. So we need a different kind of bridge, a more robust one. And that solution is the transit hub pattern. Think of a service like AWS Transit Gateway as a central airport for your cloud network. Instead of a tangled mess of point-to-point flights, everything just connects to the main hub. And that hub manages all the traffic, all the routing, not just between your VPCs, but even back to your on-prem data centers. Getting this to work across clouds is actually a pretty straightforward three-step process. First, you deploy your hub. Let's say it's a transit gateway in AWS. Second, you establish secure VPN tunnels from your other clouds, like spokes on a wheel, all connecting back to that hub. And third, that's it. You now get to manage all your routing rules from one single central place. For simplicity and control, that is a massive, massive win. But wait, before you run off and start building bridges everywhere, we have to have a little reality check. We have to talk about the hidden monster that can sink your entire project, the IP overlap problem. Let's play out a scenario I bet some of you have lived through. Your company just acquired a startup. On day one, the CTO says, hey, connect their cloud environment to our production network. We need to integrate their services ASA. Sounds simple, right? So you look at their network config and you see they've used 10.0.0.0/16 for their main VPC. And your stomach drops because you realize you've used the exact same IP address range for yours. It's one of the most common private IP blocks out there, and trust me, this happens constantly. And this overlap, it's a total showstopper. A router sees a packet for the IP range and has literally no idea which network to send it to. Direct peering is impossible. So you're forced into these horrible, complex workarounds like network address translation or NAT, just to rewrite IP addresses on the fly. It's expensive, it adds latency, and it is a monumental architectural headache. Okay, we've seen the islands, we've seen the bridges, and we've definitely seen the monster lurking in the water. So now, let's pull it all together into a clear decision framework. This is the architect's playbook. Here's your cheat sheet. If you're connecting just two VPCs in the same cloud and region, use native peering. It's simple, it's low latency. Done. For multiple VPCs, especially if they're spread across different clouds, you absolutely want that transit hub model. It gives you centralized management and scale. But for that nightmare scenario, connecting to a third party where you can't avoid IP overlap, that's when you pull out a private service connection. It's a really clever pattern that uses a service endpoint to create a connection without direct network routing, so it just neatly sidesteps the whole overlap problem. And this really brings us to the most important principle of all. Multi-cloud networking is complex. That's just a fact. Your job as an architect isn't to try and eliminate that complexity, but to manage it using the right patterns. At the end of the day, your network design has to be a direct reflection of your business's architecture. And so I'll leave you with this final question to think about. We've talked about the patterns we use today, but we all know how fast this space is moving. As the cloud providers keep abstracting away and automating more of the underlying network, what comes next? What new, more intelligent, maybe even self-healing patterns are going to emerge to help us manage all this complexity at an even bigger scale? Because that's the future we're all architecting right now.